Okay, as we do equation solving, I want you to think about there's really two ways to do equation solving, and some people prefer one way or the other, but I like to teach them both because when you're doing some mathematical thinking, it's helpful to have both tools in your toolbox, so to speak. All right, so inverses and undoing. So I've kind of been teaching it the undoing way, but I want to also like include the inverses. Uh, so let's say I had something like I had a number and I added 3/4 and it equals, I don't know, 5. Okay, so what is that number? And we'll do it both ways. So we'll do it the undoing way and the inverse way, and you'll see that they're very similar. Okay, so inverses, there are, first we're going to do added, this is additive, right? So this is an additive inverse. And the additive inverse is a term that just means the opposite. So you can use them interchangeably. Additive inverse, opposite, opposite, additive inverse. I used to play a game with my students. I say, when I say opposite, you say additive inverse, opposite. And then they say additive inverse. Or then I say additive inverse, they say opposite. Anyway, they're interchangeable, so keep that in mind. Now, the additive inverse of 3/4 would be -3/4. So I'm going to add its opposite. So plus a -3/4. And whatever I add to one side, I have to add to the other. This is the addition property of equality. Okay, so you'll see that whenever I add a number to its opposite, so this is another property. This is definitely more property based, like it's more precise mathematically. Uh, the property is the inverse property of equality. Or no, it's just inverse, property of inverses. Is A plus the opposite of A equals 0. And then the definition, this also is important, the definition of subtraction. If I take a number minus another number, that's the same as the number plus the opposite of the number. Okay, so you use these two definitions to solve this equation. So this plus its opposite, that has to be equal to 0, so x plus 0 is equal to, and then 5 plus the opposite of 3/4 is the same as 5 minus 3/4. Okay, and then we have another property here. This is the identity property. And that says that any number plus 0 is equal to the number. All right, so this is equal to just x. And then 5 minus 3/4, we would take 5, so we need a common denominator, 5 over 1 minus 3 over 4. And so the common denominator between 1 and 4, I can multiply this by 4 over 4, and that will make a 4, so this would be 20 over 4, right? 20/4 minus 3/4, so 20 minus 3 is 17/4. Okay, or if I go 4 goes into 17 4 times with one remainder, so 4 and 1/4. Okay, so yeah, we check our answer. 4 1/4 plus a 3/4 would be 5. Yeah, so it checks out. All right, so this is using additive inverses. If you did it by undoing, so we're going to subtract 3/4 from both sides. And it would be just as long if I did it step by step, but just to save us some time, we're going to say, well, 5 minus 3/4 is 4 1/4. So that's what you get. Now, what about multiplication and inverses? So the multiplicative inverse. The multiplicative inverse, this term is equivalent to reciprocal. And all it is the fraction flipped over. So if I have, I don't know, 3/4 of a number is equal to, how about 9? That'll work. So 3/4 of a number equals 9. So if we use the multiplicative inverse, what we're trying to do is turn this number into a 1. And we have this inverse property of multiplication, just like we have our inverse property of addition. And it says that any number times its reciprocal, which we can say is 1 over a, is equal to 1. And then we can use our identity property of multiplication. And that says any number times 1 is equal to the number. So we use 1 over 3/4, which is 4/3. So 4/3 times 3/4 equals x. And whenever I multiply one side, I have to multiply the other. So 9 times 4/3. And what I get is a 1, right? And 1 times the number is just the number, so that's x. And then 9 divided by 3 is 3, and 3 times 4 is 12. So I get my number is 12. And that's the way you would do it with inverses. Now, if you want to think about undoing, I'm undoing multiplying by 3/4. So now we use our definition of division. Our definition of division, just like our definition of subtraction, if we have a divided by b, it's the same as a times the reciprocal of b. So I'm going to divide both sides by 3/4. And division is the same as multiplying by the reciprocal, so I get anything divided by itself is 1, right? That's also a property, right? So yeah, a divided by a is 1. So we get 1x is equal to, and division is multiplying by the reciprocal, so I flip it over and multiply. So I get 3 times 4, which is 12. So I get the same answer either way, and they're very similar. They're just kind of using the terms in a different way. So I just wanted to present both of them to you so you can kind of choose the way you want to go. It might be simpler for you to solve a problem like, I don't know, 3x equals 9. You just say, okay, I'm just going to divide both sides by 3, and that's equal to 3. It might be simpler for you to do an undoing method there. But when you get a fraction, this might not be as easy to think as an undoing method. This might be easier to think of it as a inverse method. So I'm going to multiply both sides by the reciprocal, which makes it 1x, which is next, and then 17 times 4, whatever that is, over 3. So I'm not going to do it now, but leave that for you.